in this short video I want to demonstrate the magnetocalorific effect on a small piece of gadolinium. The magnetocalorific effect is when a material heats up in the presence of a magnetic field and cools down again when that field is removed. In order to achieve a significant increase in temperature, I wanted to build a kind of super magnet. I'm just going to very briefly outline how this has been done. So started off with a transformer which was kindly donated by an electrician friend of mine. This one was called Nigel. We cut him up with the angle grinder, and inside what we find is the guts of it, and this is made of laminations of silicon steel. So the reason we've chosen the silicon steel is because it has it generates a very high magnetic field. The highest we can achieve with sort of cheap, freely available materials. So having cut out these laminations, I then glued them together and very, very carefully assembled this pile of magnets. We have a large inch by inch, and then we have some 20 mil by 20 mils, and you may be able to see the laminations there. And what we've done with this is put each magnet on so that the north face is attracted to the silicon steel. They don't want to go on. This is quite difficult because the repulsion of the north field is only just being overcome by the pile of silicon steel. But we can be assured that this is now completely saturated magnetically, and it should be giving us an output of around about 2.4 Teslas. Okay, so I'm just going to set up the experiment now. We have a bit of insulating tape. We have a small piece of gadolinium, approximately 3 grams. Okay, putting that there, and I'm going to put my thermometer mouth over it and then tape it on. Belt and braces, wrap that around. Okay. When we turn the thermometer on, we can see that the ambient is around about 13.5, 13.6, 13.7. And if I then apply it to the super magnet, we can see that that is rapidly rising. And we've gained at least a degree, over a degree temperature rise, 1.2 degrees, 1.3, 1.4, 1.5. And when I remove it, that drops back down again quite quickly. I'll just repeat it one more time. Starting point there, 14.4. And when it's not being filmed, we can achieve a temperature increase of about 1.6 or 1.7, but obviously it's a little restrictive in positioning. Okay, so I think that successfully demonstrates a significant rise in temperature on the gadolinium when we can manage to force almost 2.5 Teslas through it.